So let's walk you through this. A student heated a known mass of zinc powder in an open crucible until there was no further mass change and recorded the final mass. What would the student be able to derive from this data? So first, let's see what information we actually have. So first, we have the known mass, so the initial mass of the zinc. Next, we also know that there is no further mass change, which means that the reaction has gone to completion, and in this case it is the reaction of zinc with the oxygen in the air because it is an open crucible. So that will give you zinc oxide, which is what the question later asks us about. Next, we also have the final mass that is recorded. So that would be the mass of the zinc oxide. Just write it like that for now. And we can also find the change in mass from the final mass, deducting the initial mass. So that will give us the mass of the oxygen that has reacted with the zinc. So let's look at the options in this question. So first, percentage composition of zinc oxide. So what is percentage composition? So it is the mass percentage of each type of element in the compound. So for example, how much of the total compound is made up of oxygen and how much of the total compound is made up of zinc, and that's measured in mass. So can we find that given the information that we have? Well, first, for the percentage composition of zinc, we can find that given the mass of zinc over the mass of the zinc oxide, which we have here as the initial mass over the final mass. So we can find that, and you can also find percentage of oxygen the same way, or you can do it just by having 1 minus the percentage of zinc, which will give you the percentage of the oxygen, because we know that this is a purely zinc and oxide compound. So therefore, yes, we can find the percentage composition. Next, the empirical formula. So for the empirical formula, that is the simplest ratio of the elements that are in the compound. So in this case, you can rewrite that as the moles of zinc to the moles of oxygen. And we can find moles just in general from measured mass over relative formula mass. And for zinc, the mass is the initial mass, and you have the relative formula mass, which you can find from the periodic table. As for the moles of oxygen, that is the change in mass and also the relative formula mass, which you can find from the periodic table. Therefore, yes, you can find the empirical formula for zinc oxide. So how about the last option, so the molecular formula? So you may be tempted to say that yes, you can find the molecular formula of zinc oxide from the given information because of similar questions in the past where you have the known mass of zinc powder. However, although you have the empirical formula, so let's just keep it as x because we don't have actual values here. So you don't actually know the mass for one molecule. Instead, you just have the mass of the entire compound. So that can be however many molecules there are. Mass of entire, let's say entire container of unknown number of molecules. What that essentially means is, so for example, if it had an empirical formula of ZnO2, let's say, The molecular formula could be ZnO2, it can be Zn2O4, it can be Zn3O6, and so on and so forth. So you don't actually know the molecular formula of zinc oxide, which means that the answer for this is A.